The house of the future is filled with building materials of the future. Materials that are durable, sustainable, and recyclable. And here it is! Concrete? Wait a minute. Concrete has been around for like forever. There's nothing new about this. This lump of cement, sand, gravel, and water has nothing new to offer. Whoa, wait a minute. Huh, this isn't concrete. Oh, this is the new AAC I've heard about. It's Autoclaved Aerated concrete. I was only kidding. Sure, I'm strong. But this building material of the future is doing all the work. It's made of many of the ingredients used in concrete, but comes in at 1/5 the weight. Why? To find out, we're gonna have to do some investigating.
Even though AAC has been used in Europe and other parts of the world for about 75 years, it's just now being introduced to the US market. Why? Not only is our building industry slow to adopt new technologies, but the factory used to make this stuff is pretty expensive to build. This Aerated factory, just outside of Orlando, Florida, operates like an enormous bakery, and with good reason. Making autoclaved aerated concrete is a lot like making a giant loaf of bread. AAC uses many of the same ingredients found in traditional concrete. The first are sand and water. The sand is pulverized by 35 tons of 1-inch steel balls inside this rubber-lined mill, creating a superfine slurry. They coat a mold with a vegetable-based oil, and then pour in the mixture with the rest of the ingredients, including cement, which binds the material together, and a small amount of aluminum powder. These rods vibrate the mold to settle the material and shake out any air bubbles. While the mixture is still liquid, they strategically place steel reinforcing bar, or rebar, which will turn this batch of AAC into structural panels. Then, just like bread dough, it's off to the 125-degree proofing room. Over a 4-hour period, the aluminum powder in the mix reacts with the cement. It acts like baking soda to form millions of tiny air bubbles inside the material. And this is going to be important. After it's removed from the mold, the material is so soft they can use piano wire to cut it. Various cutting tools shape the material, carefully working around the rebar inside to create reinforced slabs and blocks. Next, it's popped into the oven, or autoclave, for 10 hours at 300 degrees. These ovens are 135 feet long. So long, they stick out the other side of the building. When the concrete cures, what you end up with are lightweight, strong, versatile chunks of AAC. After a quick separation pass, it's loaded onto pallets and shipped.
This propane torch is blowing at 3,200 degrees Fahrenheit, but the material on the other side stays cool to the touch.
How does it do that? Thanks to the millions of tiny air bubbles inside caused by the aluminum powder, AAC has excellent thermal insulation qualities. Heat can travel by the circulation of air currents called convection. When heat is applied to one side, convection moves the heat through the air bubbles inside. With millions of bubbles, it takes a long time for the heat to travel from one side to the other. This resistance to heat flow is called an R value. An 8-inch thick slab of AAC has an R value of 20.
About the same as fiberglass insulation. The air inside is also a poor transmitter of sound, so it has excellent acoustic properties too. But being a good temperature and sound insulator is just the beginning. Now consider the fact that it's made of concrete. It doesn't take long to figure out that it's incredibly fire resistant. I mean, this stuff just doesn't burn. That alone is a great reason to use it in buildings. It doesn't rot, warp, rust, corrode, or otherwise decompose. And hey, look at that! It's so light, it floats! And I could go on and on and on about the benefits of AAC. Okay, I will!
On the construction site, working with this stuff is surprisingly simple. It can be worked with saws, drills, and routers. It's easier to move around because of the reduced weight. When steel reinforcement is added, it can be used for floors and roofs, and it can resist severe weather like hurricanes and tornadoes. It's also earthquake resistant.
Ooh, look at this! It can be crafted into beautiful organic shapes that are befitting of the house of the future. And here's the kicker. It can be finished on the inside and outside with just about any standard building material. Stucco, siding, brick veneer, paint. I love you, Autoclaved aerated concrete. So, there you go. A material that's been around for a long time and just now getting its start in the States. One of the building products of the house of the future.